Hello everyone, and today we will do another LeetCode question, which I just done one LeetCode Dare question. Today we're gonna do this question, and this question appeared in the last contest, which I'm not able to solve it. But I say I got the right gist of like how to solve it. So like in my implementation, something went wrong and I couldn't figure it out. So I sort of like, hey, maybe we can do it today. I'm gonna just delete everything that I have written in my just all the things I've been trying to do in the contest, but I fail. Actually, I should show you guys my submissions. It's like it's terrible at that contest. I'm like desperate try to submit, but it just never pass. Yeah, and hey, for this problem, I'm thinking. So my first idea is to using a dick. My idea should be correct. So I'm thinking like using a dick to track the to track the first increasing it's called non-increasing order array. Okay, let's quit that. And another dict to, of course, to track the non-decreasing order array. And the thing called again. So the thing never changed. I forget what that called. The thing. Okay, let me just search up. Things not change. Things not change. Algorithm. Sort of like it means constant, but I forget what that called. It's weird, but I really want to know because it should be a vocabulary that I should be using. Okay, this is so dumb. I'm sorry wasting your guys' time, but feel free to jump over like another 2 minutes when I find the what I called. Things not change. Verifying the algorithm. Empirical analyze, not that. Formal reasoning. Profile induction. Okay, this is induction. Oh, it's called invariance. So the scene never changes. So in my DQ, the scene never changes. My first element should be always the. So let's just take a look of non-increasing one first. Non-increasing one, the thing I want to maintain is that the smallest element always at front. And suppose there is more than one element in my queue, then it means that it's not in non-increasing order, and that's my ideal. And let me show you in practice. So such that which are using the case that been given. So this array and this k, and how my non-increasing order array work is first I insert 2 and then I insert 1, but 1 is more than 2, then I pop out the 2 and let 1 replace that position, and then in this case the side equal to 1 means true, and then another element being inserted 1 and it's more equal to the last element, so I pop out the previous one and still true, and then another one still true, and 3. And in 3 case I couldn't pop out, then I just keep it like this way, and then it's no longer true, right? And then I will do 4. So it should be 1 3 4, and then at this case 4 cannot pop out 3. And also another thing need to notice is that this 1, right? So basically this 1 should be kicked out because sort of the k equal to 2, so 1 is out of range. Sort of maintain this kind of structure, but it doesn't work. And also seeing that the discussion, people seems using prefix array, and actually I'm not too sure like how they made it. maybe I should have a closer look. So to prefix array for one decreasing and one for increasing, that's similar to my idea, okay? And then check if the dic, oh, what dic? Oh, interesting. Shit. I mean, this is so simple. I mean, like what I'm thinking. So my idea is running not that great, to be honest. It's terrible, dude. It's terrible. Ah, god damn it. I'm trying to maintain this thing, but I think something went wrong. Some sort of combination of element will make my approach doesn't work. But after I seeing prefix array, I realized that it's not that complicated, right? It shouldn't be that complicated. It's very easy if you use prefix sum, right? Crap. Yeah, I think I got how to do this problem now. I mean, yeah, let's implement here. So, the idea is very simple. So it won't increasing. I mean, wait. Let me just think. Let me just like trying to organize my sentence here. So, what prefix sum array store? We just take example for non-increasing order array, okay? And we want to maintain. I mean, we don't have to maintain it. We simply stored use an array. We create an array and store the increasing, the non-increase, the maximum non-increasing order array. Just stop here. Add this index. Add this index. And similar idea for the non-decreasing order array. And yeah, I think that's it. It's very simple, right? It's not prefix sum array, it's prefix array. So it's always using the result from last outcome. So suppose that there is a sequence like x1, x2, and it's just maintaining the non-increasing order until xn. And here, suppose that we got another element which n plus 1, right? Suppose that xn is also smaller than or equal to xn plus 1, then what we need to do is simply store the just call it non-increasing n plus 1. What I mean is like we store this number at n plus 1 index, and it solves our problem. And it makes the question such a simple problem, but in the context I didn't think of this way. I'm trying to maintain this structure, and something went wrong. I'm really not sure, like so for the deck structure there is one thing I was thinking of. Is like I can talk it here. So suppose that I got an non-increasing array, and this increasing array would something sort of look like this. And then here I got another element which is supposed to be 1. And in my algorithm, suppose that this happened, I should be kick out all these 3 elements. But in reality, I cannot do that because I want to maintain a non-increasing order array, right? But let's be honest, I should only like so non-increasing order. So my non-increasing order is like here. It's these 2 elements cannot be affected. So here, like I could have some element that's smaller equal to, actually no, what I'm thinking here. So I forget about it. So it's hard to explain my idea. It's just a weird and it's a weird idea and bit forget fiddly. Yeah, it's a bit fiddly to describe. It's not a good idea, but this prefix sum, I mean not prefix sum, it's just prefix array will solve the problem, and that's what we're gonna do. Let's create non-increasing. Just create non-increase. Is that a good name? Okay, anyway, and it should be 0. Great, and non-decreasing. And we're gonna just do it here. And we should start with 1 because yeah, there's like it's not really like anything. So if suppose that no, oh sorry, nums I is greater or equal to Then what I do here is something, but let me just write our structure first. So suppose that is greater equal, then it will be non-decreasing, and if suppose that is more than equal, it should be non-increasing. Non-increasing. And in this case, we just use non-increasing I equal to non-increasing I minus 1 plus 1. And also like after I'm thinking like it should be start with 1, right? Because the element itself is non-decreasing. And suppose that this happens, then I should do this, right? Because suppose the equal case, then the two both should be counted. And yeah, great. And here it should be non-decreasing. Yeah, I think that's it. And now we can just do it. Vector int return. Declare it, and for int I equal to k, I minus nums dot size minus k, and then I plus plus, and suppose non-increase I minus 1 is equal to k. Greater equal to k should be, and non decrease I plus k, I think. Should be I plus k, I think so. Also greater equal to k, then we do is it dot push back I, and then return it. It seems working. Cool, and let me try some different idea. 8, 9, 1, 2, 3, 4, 5. I don't know, just some random number, doesn't matter. Great, it's working. Let's try 1. Great. Actually, some HKs that I've been encountered yesterday. I have to get 3. Okay, let's do that. Seems working, and let's try some big one, a bigger case. So copy paste some number, doesn't matter, and I try 4, suppose. Seems working. Submit. Oh, this error. But this just makes it such a simple task. Great. And how did I only beat 20% people? I feel like it's pretty efficient, but hey. Okay. You only have one prefix, suffix. Anyway, I think I will take that, and that's how you solve the fun argue index. Thank you for watching.